Alrighty, good people. You're going to find out that we have different shortcut rules for different situations, right? We have now come to this point where we have five different specific function shortcut rules to find the derivative: the power rule, the sine x rule, the cosine x rule, the e to the x rule, the natural log of x rule. Five rules. But if you notice, those are five different functions, right? We have the trig functions, we have the e to the x and ln x, and then we have the power function rule. So five different types of functions. But what happens when we start mixing them together? So in my head, I kind of think of this as being the operational rules, because we already talked about what happens when I'm subtracting two things or when we're multiplying by a constant. For example, here we have this function f of x is equal to 5 times g of x minus 3. So to find the derivative, well, we have to find the derivative of the first term minus the derivative of the second term, right? We can find the derivatives of each one separately and then subtract those answers, because there's a rule that allows us to do that. And the answer here would be 5 times g prime of x, because we took the 5, we held it, took the derivative of g of x, and then multiplied times that 5. Minus the derivative of 3 would be 0. So really, this would be the derivative. Easy peasy. The question is, what if I wasn't multiplying by a constant? What if I actually had two functions multiplied times each other? Is it possible to just say, oh, well, then the derivative is the derivative of the first times the derivative of the second? Like, is that it? And so we get an example here to kind of try to figure it out if that is the case. If it's as easy as it sounds, to where we can just find the derivative of each function and then multiply them together. So the first method is this. Let's test this out. How do we test it out? Well, we have a first function, we have a second function. So we're testing out, is the derivative of this product, because I'm multiplying, and that's what a product is, the result of a multiplication, is this just the derivative of the first function, which would be 6x minus 0, times the derivative of the second function, which would be 4 plus 0. I guess in the end, this would be 6x times 4x. I'm sorry, times 4, which would leave me with 24x. So the question is the derivative as simple as just taking the derivative of the first function times the derivative of the second function? Again, what's different about this is not a constant. I can't hold it and then take the derivative of the other one and multiply back. And also, we haven't done this. We haven't seen this happen, because all the problems we've done so far have been single term functions that are being added or subtracted. Here I have this whole function in the first parentheses times the second function in the second parentheses. So the way to check if that's the actual answer is, let's rewrite the function by just distributing, right? Like if I do this times this, and I get 12x to the third, and if I do this times that, and I get 21x squared, and if I do the inside ones, I'll get minus 8x, and if I do the last ones, I'll get minus 14. So instead of thinking of it as a function times another function, what if we multiply everything out? And now there's only addition and subtraction, so I can take the derivative of each of those pieces and keep those operators there. So when I take the derivative now, the derivative of this is going to be 36x squared plus the derivative of this is going to be 42x. The derivative of this is going to be minus 8, and the derivative of this would be minus 0, so that's really not there. And so therefore, it turns out these are not the same, right? This is the actual derivative. I know that because all I did was I distributed the terms and I took the derivative of those terms. This was our test to see if the shortcut of just taking the first derivative times the second derivative and multiplying them together, if that worked. And the answer is, well, no, it didn't work, because it's not the same thing, right? So the question is, obviously method number 2 is correct. We know that because we just multiplied them out, but this method doesn't always work. because we don't always have polynomial terms in order to multiply out. We don't always have polynomials. This is a polynomial, right? We can actually multiply this term times this term times that term. But what if it was something like, I don't know, cosine x times the square root of x plus 5? Well, you could say, well, I'm going to multiply this out. Well, you're right, but now you're going to have a product here and then a product there, and how does that work? So the moral of the story is we need a better rule. And the way we do that is with the product rule. So the product rule is specifically used whenever we are multiplying two functions. We cannot take the derivative, two derivatives, and multiply the two derivatives. We can only take one derivative at a time. As a matter of fact, one of the notes on the bottom here is, in calculus, we only take one derivative at a time. So when we write the product rule, the formula, this is the shortcut formula. If I'm multiplying two functions, and I'm going to underline them in blue and in red, if we're taking the derivative of two functions, we take the derivative of the first, let me be color consistent, we take the derivative of the first, and we multiply it times the original second function. And then we add the derivative of the second function multiplied times the first function. So the product rule says, if I have two functions that are being multiplied, take the derivative of the first times the second function plus the derivative of the second times the first. If you don't want to write all of this out, we can express the product rule in terms of u and v. The derivative of u times v is the derivative of u times v plus the derivative of v times u. Try to put the little tail to distinguish them. But u prime v plus v prime u. That's the product rule. And the product rule is going to help us in many situations so that we don't have to multiply this out. I guess the other, when we were looking at this example of why does the method not always work? The other thing is, what if we had something like 3x cubed plus 2x plus 5 to the fourth power? I'm going to have to multiply all those out. I'm going to have to do this times this times that. You get the picture, right? 4 times? Well, I don't have time to do that. So the product rule says there is a shorter way. So we're going to practice the first two here in this video, and then we'll come back and practice more. So example 2. I want to find the derivative of f. Oh, but I'm multiplying two functions. It's the multiplication or the product of two functions. So therefore, we're going to take the derivative of the first. As you're learning the product rule, I sometimes tell students, write out what you need to do before you actually do it. Sometimes it might seem like it takes longer, but it really does direct you on what you need to do. So I'm already writing while I'm talking, and I'm going to go back and I'm going to tell you what I just did. I have two functions. I have x squared. I'm going to call that my first function. I have sine x. I'm going to call that my second function. So the product rule says we need to take the derivative of the first function and multiply it times the second function, the original second function. Plus, we're going to take the derivative of the second function and we're going to multiply it times the first function. After that, all I have to do is take two derivatives and I'm done. The derivative of x squared would be 2x times sine x plus the derivative of sine x is cosine x times x squared. And if I want to factor things out to clean things up, I guess I could factor out an x because both of these have an x here and this one has two x's. I can factor out an x. But really, I don't need to do that. I can just leave it like that. Or I can do this. Either way, this is the answer, this is the answer. I set up the first line as a blueprint for what I need to do, but otherwise I just did the product rule. I'm going to pause the video here. I'll let you look at that a little bit more closely, and we'll come back in the next video and do some more practice.